You might imagine that AI reads a sentence the way we do, word by word, letter by letter. Does not. First, the text is split into small pieces called tokens. Token is like a language building block from the model's point of view. It might be a whole word, part of a word, one character, a space, or a punctuation mark. For example, the word unbelievable may not be one piece to the model, can be split into pieces like un, believe, and able. Chinese works differently too. A model does not always cut text according to human word boundaries. One character may be a token, or a common phrase may become a larger piece. So the first key idea is this. Token is not the same thing as a word, and it is not always the same thing as a character. Tool that cuts text into tokens is called a tokenizer. Think of it as a knife plus a huge dictionary. Does not cut randomly. Common pieces are kept as useful chunks. Rare pieces are broken into smaller chunks, so the model can still handle new words. Tokenization. The model still cannot understand the pieces directly. Each token is looked up and turned into a number called token id. Token id is just a stable label in the tokenizer's vocabulary. Different tokens get different ids, different entries in a dictionary. But the id itself is not meaning. It is more like an address. The neural network actually uses is a vector connected to that id. A vector is like a coordinate, places the token inside the model's learned semantic space, where related pieces can be closer in computation. So when text enters a language model, it roughly goes through 3 steps, becomes tokens, tokens become ids, and ids become vectors. Only after that does the transformer really start computing. It does not see a beautiful sentence. It sees relationships among vectors. This also explains context length. A model's context window is not measured in pages or characters. It is measured in tokens. Prompt uses tokens. The model's answer uses tokens too. Long documents are expensive because they fill the context window with more pieces. That is also why many AI APIs charge by tokens. You are paying for the model to process input tokens and generate output tokens. Generation has another important twist. The model usually does not write the whole answer at once. Predicts the next likely token. It looks at the previous tokens, estimates which next tokens are likely, chooses one, appends it, and repeats the process. That is why AI appears to type piece by piece. Strictly speaking, it is not always typing letter by letter. It is generating token by token. Creates a useful illusion. We see natural language on the screen. Inside the model, there are token sequences, vectors, and probability distributions. Tokens also affect multilingual use. Different languages, writing styles, spaces, and symbols can produce very different token counts. The same meaning in Chinese, English code, or emojis may use very different numbers of tokens. Code is a clear example. A bracket, an indentation, or a variable name can become part of what the model has to process. So when your prompt is very long, the model is not annoyed by length. Context window is simply running out of token space. Once you understand tokens, large language models become less mysterious. They first translate language into computable fragments. The surprising part is that, with enough training and scale, those fragments can support explanation, reasoning, translation, and code. So remember the simple version. AI does not directly read words the way humans do. It reads tokens, and tokens are the doorway from language into computation.